Okay, so let's continue this journey in chapter 21, and now we're going to introduce the biogeochemical cycles. And I know that sounds boring. If you took geology, you might have already gone over this, but let's introduce what it is. Click, click, there it is. All right, so energy is going to flow through the system. As I mentioned, it does get lost between the different layers. So the primary consumers of energy is going to be the producers. And then what we're going to see as the consumers eat the primary producers, we start to lose a little bit of heat each time. And then we know how important the decomposers are because they're going to break down all the dead animals, the waste products into smaller inorganic molecules that the primary producers will actually use. Now, matter is made up of living organisms and it's going to be recycled. So we're going to see these different cycles between carbon, nitrogen, hydrogen, oxygen, phosphorus, and sulfur. So what you should appreciate when you look at these pictures is how things are being recycled between both the water, the land, and the air. Now, what the biogeological cycle, is the recycling of inorganic matter between the living organisms and the environment. Now, one term that is thrown out here, and it's on the next slide too, is what is the hydrosphere? So this is the area of the earth where water movement and storage occurs. So it's going to be kind of like right on the outside part right here. Now, water can be in both in liquid and solid on or beneath the surface of the earth, and it's most primarily stored as water vapor in the atmosphere. Now, one thing you should appreciate is all these elements are interconnected, and you're going to see water is going to be crucial for all these because it is essential for moving these elements between the air and the land. So the first one's the water cycle. Now, as I mentioned, the hydrosphere is just the area of the earth where water movement and storage occurs. Now, if we look at the total percent of water, 97.5% of it is salt water, and only the small percent is fresh water. And when we look at where the fresh water is stored, 99% of it is stored in ice or locked up in groundwater. So only 0.3% is what we see in lakes and rivers, which is quite fascinating. Now, we have to adapt because we need fresh water. We are figuring out ways to get more availability, and it's kind of interesting. We have all this salt water, so desalinization is a process that people are looking at. Now, water, I want you to appreciate, it's really driven by the sun's energy. So you've heard of evaporation and condensation before. So evaporation is where we go from water to water vapor. So think about like on the surface. The sun's going to come and it's going to cause evaporation, and eventually it condenses into the clouds. Now, sublimation is maybe a new term. This is where we go from ice to water vapor, because this does happen in cold areas too. So condensation is where we go from the vapor to the liquid form, and then it can come down back to the earth in the form of rain or snow. And then we also need to consider we also have subsurface water flow underneath. And also you see how everything is kind of just flowing back into the oceans and, coming from one area and down. It's like a big circle. But eventually you have it going up in some areas, coming down in others. But you should appreciate that, it's a big cycle overall. Now, the carbon cycle is just the movement of the carbon molecule, and carbon is super important. It's a part of all organic molecules. We talked a lot about how carbon was being recycled in photosynthesis and cellular respiration. So remember, in photosynthesis, we're taking carbon dioxide and water, converting it to sugar and oxygen. And then for cellular respiration, it's pretty much this equation just flipped on the other side. So the carbon, one way it's recycled is through the biological carbon cycle with living organisms. So we're constantly doing that, with each other. Now, a lot of the carbon dioxide is going to gather up in the atmosphere, and it is contributed that way through various things. When we are burning fossil fuels and non-renewable resources, we are contributing CO2 to the atmosphere. We also have it contributed from the reservoirs in the ocean, but also we have a lot of photosynthesis that does happen in the ocean. It also happens through, we have a contribution of carbon through soil runoff, and then what we have in the soils leaching and runoff, weathering of rocks. So just like before, you can see there's contributions, give and take to the atmosphere, to the water, and it's just kind of all moving back around each other. Now, the nitrogen cycle, about 78% of the air is composed of nitrogen, and this is where bacteria come in a big role right here. So nitrogen becomes available to living organisms due to the actions of these into-fixing and denitrifying bacteria. So they go through this process, they do ammonification, where they convert nitrogenous waste from living animals to the remains of dead animals into ammonia. Sorry, I mentioned this is my strong area. They can go through nitrification, where they convert to nitrates, then it goes to nitrites to nitrates, and denitrification, where they convert nitrites into nitrogen gas. So a lot of work by the bacteria that are going to be doing this right here. But you see a lot of it going back into the atmosphere, then coming back down. Now, we do contribute to the combustion of fossil fuels and fertilizers. Nitrogen is a big component of fertilizers, along with phosphorus and potassium, NPK. So this is one thing, and if you do have an excess of nitrogen, we can get that thing called eutrophication, where you excess growth of microorganisms. And when that happens, we start to have a deplete of oxygen, and we start to see like these dead areas. I always think of it like the green sludge when you see in areas of like fresh water, especially. So the phosphorus cycle, not too extensive as the other ones that you've seen before, but remember, phosphorus is a big component of nucleic acids and phospholipids. Now, where does it all come from? Well, we do contribute a lot of it from human activity. We have a runoff because a lot of our fertilizers, volcanic ash is a big contributor right there, and a lot of aerosols that we use. It has been shown that organic ocean animals, their excretions is actually a big contribution too. This process is a lot slower compared to the other ones. Like as I said, it can go from hundreds of thousands of years. Now, an excess of phosphorus in an area can lead to a dead zone, which means it will go through and kill all the natural stuff in there. It's often associated with excess nitrogen. Like I said, it causes that eutrophication, and it will lead to an area where pretty much everything will die. And then the last one in this section is the sulfur cycle. And this is one of those less well-known too, but sulfur is very important for your macromolecules, and especially when it comes to bonding and protein folding. Now, we have some in our atmosphere. It's found in sulfur dioxide. And how does it get there? Well, from decomposition of organic molecules, volcanic activity, and we have these geothermal vents that are actually just naturally contributing. Now, it is given to the land, and that will run down into the water, and we also have it where it directly falls out from the atmosphere. Now, if we do have an excess of sulfur gas in the atmosphere, this is what we can attribute to acid rain. So not as extensive as the other ones, but it's there. So that's all they talked about. I tried to find a review video on each of the cycles that you can watch, and then here is credit for my slides.